Hey programmers, welcome back, and in this video we're gonna learn all about integration testing and its best practices using Node.js. While unit tests test components and its methods in isolation, integration tests test these components as a whole, as a system. As always, you can take this knowledge and apply it to any other language that you or your team uses. And with that said, let's get started. Alright friends, so we're gonna start by defining integration tests. So integration tests are gonna live within the testing pyramid in between unit tests and E2E tests. And as you already may know, the higher you go within the testing pyramid, the higher the costs are. Meaning the lower one, the unit tests, are the fastest to execute and write, while E2E tests are the slowest, although they also bring a lot of value. And integration tests are in between, kind of a glue. Now, as Wikipedia defines it, integration tests take as an input these modules that we want to test and groups them in larger aggregates. What does it mean? Well, first of all, we are also going to look at the code to better understand it. Now, this is a normal project which has basically an index.ts and index test.ts, and this project is capable of integration testing. Now, I want to give a quick shout out to Florian for making this great repository that I also cloned in order to demonstrate it to you. So if you want to try it out, go clone this repository as well. But going back to our code, we're going to see that our testing environment, it spins up a MySQL database and connects to it. Now, what we want to test in our tests is the following. We want to be able to create some to-dos and save them in the database, and later read those to-dos and assert the response. And then also we can post something and then check the to-dos that the additional to-do has been added, and also delete the to-dos. Okay, very simple. Now, how do we achieve this? There are multiple ways of achieving with this. First of all, you can install a MySQL database locally and start testing it and connect to it by just giving your port, username, and password, and so on. The second option would be starting a Docker container. Okay, Docker containers could be started with Docker Compose, for example. I even have a Docker Compose file. All right, so we're gonna define a MySQL image, and we can also define a Node image where our tests are gonna be running. Now, let me tell you something. These both options are not ideal, because what if you give this Docker Compose file, or you have to test this test on someone else's machines, for example, your teammates? It's going to be very costly for them and very error prone to install their own database and then run these tests. What if instead we're going to do the following? So we're going to take a look at the Testcontainer. This is a very famous library that developers use when doing integration testing. And what does it do? It simply spins up. Let me show you what it's gonna look like. It's simply gonna spin up a container for, it doesn't matter, can be a Postgres, can be a Kafka, can be an Elasticsearch. So we're gonna set up the tests. It's gonna start the containers. While the containers have been started, we're gonna run the tests against those containers. And after the tests have been ran, our cleanup function is gonna come in and just basically going to remove those containers. How handy it is. So imagine you want to run the tests, your tests run against these images, okay, against the Postgres or MySQL, and as soon as the test is finished, these containers are destroyed, so they're not kept in the memory. Now, I also have a Docker desktop, and I have these two containers because I already ran my integration test. So MySQL 8 and Node 22 that we also saw in my Docker Compose. And these containers are simply going to be started and then removed, or rather stopped, as soon as the tests are finished. Now, we're going to try that in a second, but I also want to tell you that test containers are not fast, okay? Because every time you run your integration test, these containers have to start, okay? Just keep this in mind for now. And now we're gonna go to my package.json. I'm gonna run dev first of all. What dev is gonna do, it's gonna take Docker Compose, and it's going to make sure that all those two images that I have within my Docker Compose, so MySQL and Node 22, are actually pulled in my machine. And now I can run the test. So the test is going to target that file that I previously showed. So as you can see, we have a lot of logs here. because it's starting the containers, connecting to MySQL, and simply running the test. And now the tests have run. We have 4 specs, as you already saw, 0 failures, and all the tests finished. How cool is that? As you already saw, I didn't have to install anything locally. I don't have any MySQL locally, and I didn't have to start any containers myself locally, because if we go to our tests and we go above in the before all section, which is basically run before any test runs, we're going to see that we are actually importing a lot of stuff from test containers. Now, the first thing would be a network. It's basically the baseline for the containers that you can create. Okay. Then we're going to create a MySQL container, and using this generic container class, we're going to give in, you probably know that this is a builder pattern. I have a video on design patterns. We're going to see that we're simply passing some options. Okay, we're passing the password, we're passing the database, and so on. And we can also get the name of the network. Okay, we connect it to a specific network that we define here, and we start it. And now we have our MySQL container running and access to it. Also, we're going to start the API container where our code is going to be living. We expose the port, all this usual stuff that you can achieve with Docker as well. And as soon as we have started, we're going to be able to connect to it, and simply by using axios already post code to it. Okay, how cool is that? This is very easy. So everything is done programmatically via code, and we didn't have to do anything manually. Now, enough practice, I would say, because you can just pull this image and run it yourself. I want to actually explain the idea behind integration tests, because having the right mindset is more important than the practical part here. Okay, this is what I want to explain in this video. So as you guys already saw, when we were starting the test, we had a before all section, and this is very typical in JavaScript. Okay, in the before all section, we didn't seed the database, meaning we didn't insert any data to the database. First, we did add to-dos, but this was already a test. Okay, we didn't add to-dos in the before each to make some data available. And if you need this, if you have a need for preceding your database, you can actually run migrations. What are migrations? Migrations are basically files that you can define in advance, and they're going to be stacked upon each other, just like a Git commit history. And as soon as you execute a migration, your database is going to be filled with some predefined data, and the chances are high that you're going to avoid any bugs because everything's defined programmatically. I'm going to make a video on migration, so stay tuned and subscribe to my channel. Don't forget that, please. Now, since we already mentioned different testing types, specifically E2E tests, I want to give a quick shout out to my friends at Squish, which is an excellent tool for functional GUI test automation. What is cool about Squish, you may ask? Well, Squish provides an efficient and agile automated GUI testing with multi-toolkit applications. It has a ton of powerful features that can tackle any testing challenges you might have. But some that I found the most beneficial are, for example, recording and playback. You can record, edit, and execute tests with Squish without a steep learning curve. It's very intuitive. The tool also offers extensive integration options. It's fully compatible with CI/CD systems and version control, streamlining your workflow for rapid deployment. Another example for its versatility is that it's available in whichever scripting language you use. And it's especially good at testing applications on multiple different platforms. Whether you're working with Java, Windows, or anything else, Squish has you covered with powerful property-based support. There are a lot of materials on Squish online, but I'd actually recommend trying out this interactive tour so you can see firsthand how it exactly works. You really get a good general idea and feel of the tool. If you want to support my channel, then make sure to check out today's sponsor. You will find the link to the tour in the video description below. So go try it out and let me know what you think. And now back to the video. All right, now going back to our board, I want to talk about very important stuff. For example, the test container lifecycle strategies. We essentially have 2 strategies. So we can either start for example, our MySQL container, and for the integration test A, for example, for this test, let's say, we can start the container here like this and tear it down at the end. Tear down. Or we can do it the way we are doing now, start in the before all. And if I scroll all the way down, we're going to see that we have an after all where we stop all these containers, including the network. So currently we are doing this after all strategy, but we also have an option of doing after each strategy. Basically, we're going to be starting and stopping the container for each test. And you might ask, what is the benefit of each? Well, that's a great question. And this is very specific to each use case. You may want to have both just make sure that you keep in mind that this is going to be very slow because you have to start and stop containers for each small test. But if you really want to have isolation, if you really want to have a clean database, for example, for some reason, then this is an option to go. But usually going with the after all strategy is easier. Now, there's a caveat with going the after all strategy, which also doesn't affect the after each strategy. As you may already notice, in the test that we defined here, we first add the new to-dos and then we get the existing to-dos. Meaning, if we for some reason break this order and take this test out, or instead paste it here for some reason, or simply remove this test, all other tests that are coming after this test are going to be broken, okay? Because in the next test where we try to get these to-dos, there's nothing in the database. The database is empty. So it essentially means that the tests are dependent on each other. So as long as you keep this in mind and don't mess around with the sequence of the test and be very careful about them, simply acknowledge that, yes, these are tests, but they're unfortunately dependent on each other. So this is the nature of integration tests. Usually you should be good. Okay, you should be good with the after all strategy, and you also don't waste time starting and stopping the MySQL file. Another cool thing is that there's also a way of running the containers for the whole directory. Okay, imagine you have a test folder here and you have like 5 test files that are integration tests. You can make sure that the integration test, or rather the containers, start only once for them and end at the very end instead of starting the containers for each file. Although starting the containers for each file is probably a cleaner and better way. Now, let's talk about the libraries that we usually can use. So as you know, Axios is an HTTP library that you can use for making HTTP requests from your Node application, right? We will also have something called supertest. If you haven't heard of supertest, it's a library for testing your APIs. For example, in this example here, we'll be using Express and we're going to be using supertest. In Express, this is how you usually define your route. So we're going to return 200 with a JSON named John. And with supertest, we're simply going to target this exact user path and expect some, for example, content type, content length, the status, and we can also test for the errors. Okay, as simple as that. Now, your question could be, should I simply use Axios? Because in our example, we don't use supertest, all right? We, for example, get the to-dos and then do response.data equal just an array of to-dos. Well, the opinions are kind of in between. Some people don't like supertest because it's too verbose, but I actually would like to use supertest because in our example, as you can see, we are not asserting on the status. Of course, you can retrieve the status from the response, but supertest looks very neat when it comes to assertions, and I would actually suggest you using supertest as well. It's a very powerful library. All right, and now we're gonna go even further on our board and talk about mocking and testing strategies. Okay, so integration tests are very similar to how you would write your tests with unit tests. Okay, they're not much different because they also have mocking parts to it. So imagine we're making a request to a client. Okay, this is our endpoint and this is the test request that comes in. And this endpoint might not only have a connection or rather integration to a MySQL container that we saw in the code, but imagine it also authenticates itself beforehand. So let's say there's some kind of a middleware or like another microservice that it has to make a request to, and it also connects to a message queue after the insertion to MySQL has happened. It makes and sends a message to a message queue that then, for example, sends out emails. Now, how do we mock these parts if, for example, we want to only test that the MySQL insertion has happened? Well, we can, of course, simply try to use the library, a mocking library. And there's a very famous mocking library called Knock. And I'm going to show it to you in a second. So Knock is very popular, as you can see, 3 million weekly downloads. And mock is essentially going to look like this. Also very simple. So we just import Knock, we define the URL, and we define which route we want to mock. So we're going to be mocking this. And every time within our test, we call this path. Okay, we call this route. We're going to get 200, no matter if the server has started or the server doesn't even exist. As soon as we mock this, this is what we're going to get. So what I'm trying to say, we can actually mock our authentication endpoint, which is living in another microservice, as we saw here. We can use Knock to mock this authentication microservice and always reply with a valid JWT token, for example. That's later going to be used to connect to, for example, to a message queue or a MySQL. Now, there are many authentication strategies, but you get the idea. You can use Knock to mock stuff. Another point is detecting, rather documenting and detecting the undetected outgoing requests. What do I mean? So for example, when we make a request here, we don't know that about the request that has been done here, because let's say we haven't written the code. And it's a really good practice to, by default, disable them. So in Knock, you can say that, hey, I'm only mocking this part, and everything else that hasn't been mocked should be failed. Okay, and as soon as you run your test, you're going to be seeing that, oh, something failed. And then you can go into the code and see, well, apparently my endpoint also results in a message, okay, to a RabbitMQ. And then you will have to mock this too, for your test to function properly. Another cool feature of Knock would be recording outgoing tests. Well, the thing is, if something fails, how exactly you're going to know where to debug this? Well, in Knock, you have a function for recording. So you can actually record, and Knock is going to print stuff in your print logs and saying that, hey, there was actually a request going to your message queue. And then you can later mock that too. All right. Another cool thing is to remember that sometimes you want to test the bad paths. Okay. Sometimes you want to test that, or sometimes you want to mock your endpoint, for example, this localhost user, and simply return 503. Okay, in the first call. And then say that, well, now if someone retries after 100 milliseconds, I'm actually going to work and return a 200. Well, it again depends on the application, but if your application is mission critical and you really need recoverability and you want to test this recoverability, you can do this with Knock as well. Okay, so far so good. Now we're going to talk about testing outcomes. Testing outcomes are very interesting. So as we already saw, within our tests that we have here, we usually test the good path. Okay, we're going to test that, hey, we make a request to the API and we get some data. Okay, we also tested the new state. Okay, so let's say we insert some data and later we get this data that we previously inserted to make sure that the database has been changed with the new data. Where is it happening? Here. So this is where we insert, and this is where we test the new state because we get the existing to-dos. All right. Now, a cool thing would also be to test the external calls. External calls meaning what we just discussed, basically trying to mock all the outgoing requests. Also, message queues, exactly the same thing that we discussed, and also observability. Okay, what does it mean? Sometimes it's also good to use your integration tests to simply check which kind of logs have been logged to the console. Okay, because observability is very important within applications for debugging purposes. Let's say some kind of a user of your website has been getting an error. So you will be able to go into your logs or some kind of a application that tracks these logs, like Amazon CloudWatch or AWS CloudWatch. And you want to be printing these logs somewhere so that CloudWatch can pick them up. And in order to test that the logs are printed correctly, you can also write an integration test testing that, hey, my logs are being printed correctly. So don't forget about all these testing outcomes that you need to keep in mind. And also, we're going to talk about public APIs for assertions. What does it mean? Imagine we again make a request to the endpoint for testing. This endpoint calls a message queue, a RabbitMQ, but eventually this RabbitMQ message also results in a database change. So our endpoint is not changing the database directly, but rather it's going through this maze and then we end up with the new state. Well, now let's say in the next test, we actually want to test this new state of the MySQL database, but there's no API. How do we do that? We're kind of blocked, right? Well, you can either mock something in between here, usually a service, all right? Or you can try to mock something in here. So the closer you are to the end target and mocking this part, the better. Now, also a very important word here is public APIs. You have to always test your new state using public APIs and not internal APIs, okay? Because our integration tests need to be testing basically the end state using the public APIs. Okay, cool. And now, last but not least, contract testing versus integration testing. I have a video on contract testing. Go check it out. And I want to talk about the difference between contract testing and integration testing because you might be confused. They're both testing endpoints, okay? But there's a difference. For contract testing, we need those when we have different teams that are working on these API endpoints or rather services in silos. So they work independently, and in order to prevent issues later, you can create a contract and exchange those contracts, okay? So these servers have to be evolving independently and you don't have control over them. Or for example, these endpoints are public APIs and are consumed by external clients. On the other hand, integration testing is for testing endpoints and services that you have control over. And you're going to be basically confirming that all parts of this application that you have control over, for example, database interactions, third-party services, are working well together.